Welcome, calculus. We're going to do the second half of this quiz. Let me know when I got to stop. If you have questions, you want me to redo something or slow down, you go slow down. All right, let's look at this. 11, inverse functions. How do I know? I see that keyword inverse. So whenever you see that kind of stuff, boom, I'm making my box. I just start drawing it right away. I just stop, like I see that inverse, stop reading right there and make my box first. X, Y, I prime. And my functions f and g. I want to find g prime of 1. That's the down there. The f is here. Okay, set this up. Now what do I plug in? Well, now you're finding g prime of 1. That's a 1. That's a 1. And if that's a 1, thing right here says, oh, that's a 0. It'll also be a 0, but matters sure. Now to find the derivative, I got to use something else. But we got this function here. All right, I can find the prime. 3, 2x plus 1 times 2. You're going to be plugging in the 0. 3 times 0 plus 1 squared times 2. That's 1. 3 times 2. That's 6. And then you want to do the reciprocal. 1 over 6. All right. And is that an option? Sure. Your answer is D. Again, going back to that, my table. Oh, I had to derive this. Sure. I'll move on. What am I missing? All right, moving on. 12. Oh, one of these fun ones. Yay. All right, so implicit differentiation. I'm going to get dy dx div the y. Got a product rule this, so it'll be 1 times y plus x times dy dx plus 2x plus 0. Sure. Did I need to write a plus 0? No. I'll clean it up a little bit. Y dx equals y plus x dy dx plus 2x. Okay, if I'm just asked to plug in -1, oh, okay. So a few things. I'm going to have to plug in for x and y. I know my x. I actually just want to plug in the -1 right now because I think it'll be easier to do the math instead of isolating the dy dx first. But let's say I want to figure out my y. I got to figure out my y. I'm actually going to plug in that -1 to this equation. Like kind of a sidebar right here. So your y equals -1 times y plus -1 squared plus 1. So I got my y equals -y plus 2. 1 plus. Add a y to both sides. Divide by 2. Y equals 1. Okay. So if that's -1, that's +1. I'm going to plug in right now. So my dy dx equal to 1 plus negative dy dx. I'll be -2. Gotta add a dy dx to both sides. Get 2 of those. Say y prime, I'm getting lazy. I have a 1 minus 2, -1. Divide by 2. answers. There's a lot going on. Could have isolated the dy dx first if you wanted to. I sometimes I like just plugging in right away after you derive, because then I don't have to deal with so much algebra, letters every with numbers to. Yes. Check your work. That work over here. The alternate timeline. So I would take this thing, I would subtract this thing on both sides. So I'm going to get a dy dx minus x dy dx equals y plus 2x. Did you do that first? Okay. I'm going to factor out a dy dx. It's going to be 1 minus x equals y plus 2x. Did you get a 1 minus x? Okay. Brian, this is practice. Practice for the test. So I'm going to divide. Okay, so then you divide and you're going to get y plus 2x, 1 minus x. That's what you got? My guess is most people would not have this 1 minus x. They'd forget the 1. You got the exact thing. Okay. Did you get negative 1 and 1 when you plugged in the x and y? Got it. Okay. All right, moving on. Another one of these. Oh. Okay, so 2x times y plus x times dy dy squared dy dy. I'm going to isolate things. I think I'm just going to subtract 2x and subtract y on sides. Cancel out. X y squared y dx negative 2x minus. Factor out that dy dx right there. Y squared x minus y. You'll divide by the x plus 3y squared. All right, so this is my answer. Doesn't match. I love how they don't put parentheses around this, but it's implied. Then it's not really implied for this. Or is it implied up here? Yeah. They should have put parentheses. I think. Oh. Did I mess something up? No, I didn't. Oh. Oh. Oh, I don't see my answer. It looks like this, but there's supposed to be a minus here. Well, it's not B. Not C. Not D. And no. Like it's supposed to be A? But what did I mess up? Mess up the. Oh. Two x negative y x y x dy dx y squared. Practice. That's still correct. That's correct. Divide by that. Give 2x minus y over. I'm right. I think my math's right. You guys get an answer? Oh, okay. So yeah, and I see, and then they were just really lazy about their answers. That makes sense. So they factor out the -1, so it's negative, and then 2x minus y over x plus y and plus y squared. But I think they meant put parentheses around like this, but they just did a. How lazy is that? So I think the intention is like all these answers, like embarrassing. College Board, AP Trevor, if you're watching right now, this was from your website. And that's embarrassing to do this. Because obviously they did it right here. So you could have made it in fraction format. Trevor, come on. Cancel them. So lazy answers. The real AP tests I've never. Sometimes they just got some lazy questions. I don't know where they pull them from. Come on. And like the problem is like, where do you give feedback on fixing? Like I'm not going to email Trevor. Or I can add him on Twitter. I can start drama there. Who cares? This one, okay. Oh, more of this deriving stuff. dy dx equals 1 over x squared plus y squared. And then chain rule the times 2x plus 2y by dx. Cool. Now, this is where I wouldn't isolate the dy dx again. Look at that. I mean, that's so gross. Isolate that, right? This is why, like, if you just have to plug a point, let's do that. Because especially when y is 0, it's going to cancel out something. So I get my y dx equals 1 squared plus 0 squared bottom times 1 times 0 y dx on top. Ends up happening, guy goes away. Just left with 2. If you tried to isolate the dy dx in this case, you could have. Do that. You could do it for funsies. Not really fun. Does anyone want to see me try to isolate that? Okay. Okay, so this is the darkest timeline right here. Guys to do. Too late, Zoe. Someone else said yes. I'm too lazy. I'm writing y prime. So what I'm going to have to do is I'm actually going to have to break that up in 2 fractions. Like that fraction. So it's going to be 2x for x squared plus y squared plus 2y x squared plus y squared times the y prime. I'm going to put it on. Next thing I'm going to do, I'm going to isolate the y prime term. So this is a y prime term. This is the coefficient. Right. I'm going to subtract this thing, y prime, on both sides. So I'm going to get a y prime. I don't know if you guys, if I go too low, you can't see it, right? Oh, try if you can't. Okay, no, I'm just going to do it up here. Go up here. It's going to be y prime minus y x squared plus y squared y prime 2x over x y squared. And you're going to factor out that y prime, as you do. The y prime equals y prime times 1 minus 2y x squared plus y squared equals this thing. Then you got to divide by that thing in parentheses. Divide by this thing on both sides. So then the answer is this fraction 2x over x squared plus y squared divided by that nonsense, 1 minus 2y x squared plus y squared. Sure, you could simplify that, but that's so gross. Like, and you could easily get things lost in there, and it looks like a mess. So that's why I like plugging in stuff right away. Sometimes, like, if I ever get a chance, I do that. Things can simplify with numbers instead of so many letters. Go. Next one. Oh, 15 is kind of neat. So the nth derivative, right? That means, but then you got to look at the answers and figure out what the pattern is. So, oh, and then they put this factorial. Do you even know what that is? N exclamation, that's factorial. You just throw this in here. That's like, if you had 5 factorial, it's 5 times 4 times 3 times 2. 4 factorial would be 4 times. Oh, that's kind of annoying. Well, if it was a BC question, I might have done that. Okay, so how would you even approach this? So what I would do is I would just do this a few times. Y prime would be e to the n times x times n. Y double prime be e to the n times x times n. Then that end would be 2. Derive a third time. Deriving this part, e to the nx times n. You still have your times n times n. And then if you did this a fourth time, and maybe you're seeing a pattern, it's e to the nx times n. It'll be times n times n. I got a pattern going on here. And what's the pattern? I multiply by more n's. I still have e to the nx. Like, okay, not you, not you. I have multiple n's as you keep going. Not just one n. This is an n number of n, and this is n factorial. I'm not multiplying by just one n. I'm multiplying them by a bunch. I'm always multiplying by n. It's not like a decreasing number at all. So my answer is A. Like e to the nx times n to the fourth, and this would be e x times n. Oh, so this is kind of a neat kind of problem. You're kind of like understanding the higher order derivative like that. So there you go. It should have been A. What's 16? Second derivative. Okay, that's just straight up second derivative. Nothing fancy. No implicit. So your y prime is going to be negative 2 sine x over 2 times the derivative of the inside, so 1/2. Actually going to clean that up. 2's are going to cancel, so it's just negative sine x over 2. And then you derive it again. Derivative of negative sine is negative cosine x over 2 times a 1/2. Tricks there, I guess, are people not knowing their sines and cosines. Yes. Like C is only derived at once. E is track of the chain rule stuff. B is like you didn't chain rule at all. A is like you did it the wrong way. We're integrating instead. All right. Oh, this looks fun. Slope of the line tangent. So when I say slope of a line, that means the derivative at this point right here. It just means the derivative. Derivative arctangent is 1 over 1 plus, so arctangent is 1 over 1 plus x squared. I have it memorized, so it's 1 over 1 plus 4x squared times the derivative of the inside. Plug in the 1/4, so y prime at x equals 1/4. It's going to be 1 over 1 plus 4 times 1/4 is just 1. 4 over 2. 2. Didn't even need to know my trig. Hey. Yeah. Okay. Cool. Moving on. Oh my. More of these? Why did I assign 18 to you? Oh, wait. 8. Never mind. Odds. Oh, so I got to do implicits. X. What are this? I've done this so many times now. I'm annoyed. It's 1 times y plus x times y prime. Y prime equals. Look, would I isolate y primes? No. Or you just plug in again. Times 2 plus 1 plus 2 times that y prime plus 2 times 1, 2 y prime. Combine those like terms. Plus. Track that 5. Divide by 4. There you go. You've done that so much right now. So good at this. All right, let's try the last one. Okay. Oh, it's just chain rule. Got it. Derived this. We did a bunch of those yesterday. F is that and G is that. Derivative of this is what? Okay. So okay, 2 ways to approach this. You could plug the G of X in F here and then derive. But would I do it? I don't know. My thought is I would do this. I'd say prime of X, right? When you want to plug that one 3, I got to find F prime of G of 3 times G prime of 3. So, okay. So then I got to find a few things when I plug in 3. So first I want to find G of 3. G of 3. 3 times 3 minus 2. 7. That'll be F prime of 7. Now to find G prime of 3, I got to find prime of x. Derivative, that's 3. It's going to be 3. Always 3. Now, I got to find f prime of 7. So first, you got to find f prime of x. It'll be 1 over 2 square root of squared minus 4, because again, memorize, I'll keep saying this. Happens so much. Memorize that. And times 2x. Plug in that 7. F prime of 7. I get 2 times 7 on top, so 14. Yeah, I could have reduced. I'm not doing it. 2 times the square root of 49 minus 4. Oh, that's going to be 14 over 2 times the square root of 45. Oh, okay. So then I could reduce this. Maybe go, oh, now I can divide that 2. 7 over square root of 45. Then I just plug this in. So I get 21 over square root of 45. 21 over square root of 45. Cool. I go, oh, my answer should be there, right? Oh, it's not. You guys remember how to simplify a square root? Anyone know how to do this? Yes or no in chat? No? Okay. I'm going to show you my way. And you might have done it. Did you guys do it with the trees? Maybe? I'm not even going to show you the other ways. I'm going to show you my way. I do this step way. So the idea with steps is you factor out primes. What can I factor out of 45? Well, divisible by 5, so 5, 9, 3, and 3. 3's a prime. You circle the pairs, you square alones. The pairs go on the outside. The alones multiply on the inside. Have you ever done it that way? Most of you might do this. You go, oh, that goes to 9 times 5. Something like that. That's the way they teach. I like mine. So this is the same thing as 21 over 3 times square root of 5, which cancels out to 7 for square root of 5. A. Boom.